Now, just to kind of preview our speech, you're going to hear from Drew Jenkins, who's going to go over the roadway expansion improvements into this new 6-lane roadway that we're going to do. You're also going to hear from Andrew Estrada, who's going to go over the traffic volumes and the safety efforts and improvements. Then you'll hear from Leo Bia, who's going to discuss the drainage developments along the roadway and the bridges. You'll then hear from Ariana Canfield, who's going to review the bridge substructure and the soil conditions. After that, you'll hear from Joel Hernandez and Danny Fernandez to discuss the bridges over the Pantano Wash. They'll hand off to Edgar Valenzuela, who's going to do the SWIP plans and the Envision score. Will Vale will then talk about cost and schedule, and then followed by Jessica Neal, who's going to do utility coordination and community considerations. So now I'm going to hand off to Drew to go through roadway.
Thank you, Riemann. To begin, you can see on this slide the opportunities that we committed to investigate nearly 1 year ago. And since then, all the alternatives for every single one of these objects that are listed on the slide were investigated to ensure that we had designed for the most efficient product for each one of these challenges and opportunities. Every single one of these challenges were looked at as opportunities, which required the coordination and collaboration of multiple different team members of different disciplines. The successful design meetings and discussions between the multiple disciplines demanded that we found the best solution, not only for the immediate improvement of this corridor, but also the best solution for the future service and sustainability of Houghton Road as well. And the complete study of all these opportunities only exemplifies out the dedication of that T3 had to every detail of this project. As you can see, every single one of the our investigations remained or resulted in having a improvement that has created a very successful project overall. Now, as we move on to the next slide, we'll see some of the details for Houghton Road. And the design of the Houghton Road corridor itself was very much focused on safety, but not only safety for the vehicles, but safety for the vehicles and the non-vehicle users as well. And we started off by looking at the safety of the vehicles by expanding the roadway from 2 lanes to 6 lanes with a 20-foot median in the middle for a better level of service throughout the corridor. Also, for safety of the vehicle, we had eliminated the erosion along the edges. That was a safety hazard, and improved the drainage by the curb and gutter system and the different culverts that we've installed that Leo will be talking about later. One of the other things we did to improve the safety of the non-vehicle users, as you can see on the west side, and we have a 6-foot sidewalk, and on the east side, we have a 10-foot multi-use path. And on the bridge, we have a separated multi-use path with a barrier in front of it to ensure that non-vehicle users are able to use all parts of the corridor safely without being too close to the roadway or interfering with any of the traffic on the north and southbound. And all of these were considered and analyzed, so we're able to use the maximum amount of space while being able to purchase the minimal amount of new land. As we move on to the next slide, some of the other improvements that we've made outside of the Houghton Road corridor is the improvements at Seacrest Middle School and the improvements at the Escalante intersection. Beginning with the improvements at the Seacrest intersection, we had begun with one purpose, and that was to reduce the congestion during the peak hours at the pickup and drop off at the beginning and end of each day. And one of the ways that we had done that is making better turnaround stations to get in and out of the school along Houghton Road corridor, but also improve the ingress-egress for the bus turnaround so buses are able to more easily go in, pick up the students, and leave quickly. And one of the other major considerations for these improvements was the safety of the students, faculties, and parents approaching the school. And we did this by redoing the parking lot so it's a lot safer during these peak hours and also allows for a greater amount of cars to be parked. And in addition to the change in the parking lot design, we were able to add some new parking spaces for around the bus turnaround, so that way faculty that's staying late or sports coaches will be able to park there and stay out of the congestion during the peak hours. And having a larger parking lot at Seacrest will allow a bigger capacity for cars to park, which will also allow future growth for the school. And some of the other intersections improvements we made in detail is the Escalante intersection. And Escalante intersection was also designed with the thoughts in mind of safety and sustainability throughout its lifetime. And we did this by improving the roadway itself, expanding it so it has a dedicated left-hand turn lane and right-hand turn lane on the Escalante roadway itself, and also having dedicated left-hand turn lanes on the Houghton Road corridor. With the addition of the new lanes, we were able to have a new signal system that is very efficient and reduces congestion during the hours at which Seacrest is being let out in the morning and the afternoon. And now I'll leave it off to Andrew Estrada to talk about the details of our traffic engineering.
Thank you, Drew. So for this traffic design, we needed to make assumptions before we began. First, we knew that we wanted to have a 6-lane roadway since we were tying into the existing roadway to the south of Houghton Road. From that, then we needed to determine the number of projected vehicles that we would have in 2040. So first, we need to determine the volume trend. This we were able to take from PAG, which is the Pima Associates of Government. From there, we took an average, and then we multiplied that by the 20 years and got about 100% growth. This means that we're expecting the roadway to have about double the current number of vehicles it has right now. We were given 2 counts, one from PAG and one from an independent agency. We decided to go with a more conservative number by going with the most largest and multiplying that by 2. So as you can see, for the count projected 2040, we're projecting about 53,292 vehicles that would be along this roadway. Another assumption that we needed to make was the total number of easels. We predicted about 1,740,000, which is used to determine our pavement design for this roadway. We're expecting no more than about Class 8 vehicles to be on this roadway. So in our next slide, I'll be discussing the lane geometry for the Escalante Road intersection. So along with this expansion of the roadway, we needed to redesign the intersection. First, we needed to get a new optimized signal and as well as new turning lanes for the roadway. In order to determine this, we used Synchro. Using Synchro, we were able to plug in what we knew so far, which was the number of vehicles, and test a bunch of different designs to see what met HCM and city standards. So from that, as you can see in our figure 3, which is our intersection design, you can see that we have 3 lanes going both north and south, and 1 lane going east and west. Each approach has a left turning lane. However, for this project, we assume that only the north and westbound approaches would only require a right turning lane. As well as in figure 4, you can see the turning phases that we will have for this project. So we would have protected phases for just the left turns, and then we would have protected passive phases for the right turns. And then at the bottom, you can see our lanes that we determined for the turning movements based on the LOS and the delay and queuing that we see along these turning movements. So in our next slide, you can also see the analysis that we did for this roadway to determine that it was meeting city requirements. So what we look at was HCM. Synchro uses HCM, which is the Highway Capacity Manual, to calculate queuing and delay. There we looked at LOS. So for turning movements on an intersection, you want to have nothing lower than an E. For approaches, nothing lower than a D, and an intersection, nothing lower than a C. So as you can see, currently we're meeting city standards and as well as HGM standards. So we know that this roadway will effectively be efficient for working in 2040 when we would be looking at this roadway again to see if it needs any new updates. So we know that this project meets the requirements and has a lot of room for growth based on the design we've done so far. Currently, we only have right turning lanes on 2 approaches. If we add more turning left lanes, we can easily increase the serviceability of this roadway, and that we would focus on more working with the city and seeing what they want in their future design. So lastly, on our last slide, we're going to be talking about traffic safety and crash data. So from the crash data that we were given back in 2007, we saw that Escalante intersection had about 12.8 crashes per year, and Pantano Trail had about 1.8 crashes a year. Pantano Trail is a small little intersection that comes into Howland that isn't really seen, so it's quite dangerous, and as well as there's no really stop sign. And as you can see on the right, you can see a figure charting the crash severity and the number of crashes a year for each crash severity. So the most dangerous, of course, is incapacitating. That's when the driver is either knocked out or unconscious when they get hit in a car crash. And as you can see for the Escalante intersection, it was about 0.5 crashes per year. And then for the Pantano Trail, it's about a 0.6. So we know that we're going to make safety improvements to this roadway already from what it has currently. Right now, there is no median, there is no turning, no curbs. So we're adding new median, which is a 20-foot median, as well as curbs and 6-foot shoulders, which should increase the safety for the roadway, as well as new timing, signalized timing, so that vehicles can quickly move to the intersection without being delayed and people having to be in a hurry. As well as adding right turn lanes and dedicated left turn lanes so that it's easier for vehicles to turn. Another important aspect of this roadway is pedestrian. We're adding a multi-use path. They're going to be using this roadway as well. This is a very density-filled roadway that will soon develop. The area is not really developed right now, but later it will be. So we want to make sure that pedestrians have the opportunity to be able to safely cross the roadway and travel along. And that's why we're putting about a 10 space between the edge of the roadway and the multi-use path. So lastly, at the bottom in figure 13 and 14, you can see what we calculated for future crashes. We're predicting about 23 crashes or about 24 crashes on Escalante and 12 crashes at Pantano Trail. And hopefully, this is an increase from what we currently see, but at the same time, this is pretty good considering that we're doubling the amount of vehicles we have on this roadway and increasing safety for the future. So next, I'd like to pass it off to Leo, who will be discussing the hydraulics for the project.
Thank you, Andrew. For our hydraulic analysis, we focus on 8 concentration points. For the concentration points, we delineated the watershed in Civil 3D on 2-foot contours provided by the Pima County. 5 of the concentration points were calculated in PC Hydro for 100 years, and while others were given by the city of Tucson. Notable washes are the Pantano Wash and the Old Spanish Wash. The Pantano Wash is a FEMA regulated zone, so it has extra requirements such as no rise. No rise it cannot rise in elevation of 0.1 feet. On our next slide, for our hydraulic features, the culverts, we designed 8 culverts from a 1.1 to 1.5 ratio for the culvert height to the headwater. For culvert 5, we were able to extend it since it already dissipated the existing discharge of the wash. And for culvert 8, the sedimentation value was over 1. So for that culvert 8, we would possibly need to maintenance in the future. Also for right-of-way, we designed the culvert such that it does not rise over 1 foot from existing to proposed. And for erosion mitigation, it follows the no rise or the right-of-way requirement. On our next slide, we will go over the Pantano Wash Bridge. So for this bridge, we cut out a cross section in order to have an extra area for discharge to go under the bridge. This was done since the existing bridge only had a 0.5 feet of freeboard, and our proposed now has 5.0 feet. The required of 3.0 feet was increased to 5 since we cut out a cross section. There's potential for equilibrium sedimentation, so there's possibly a less cross section in the future. So we did that for potential sedimentation in the future to accommodate that. Now I'll pass it on to Ariana, our geotechnical lead.
Thank you very much, Leo. So yes, I'm going to be talking about the geotechnical and roadway design aspects of this project. And so we're going to start with talking about the piles under the bridge. So to start with, we were given 5 borings. They went down 126 feet. And they were located at 5 locations along the bridge track. So what we found looking at these borings was almost all of this was sand. We didn't reach the water table in those 126 feet. There was no bedrock. There was no caliche. It was basically sand all the way down. Because the measurements were taken using the standard penetration test, we used a method for calculating the force that a pile can sustain that directly uses values from that standard penetration test, and you can see the results of that on this chart here. And these different colors show the different diameters, so that's 4, 6, and 8 feet in diameter. And the other thing we had to consider was the scour. So the predicted 100-year scour in the 100-year flood is 51 feet. So those first 51 feet we assumed provided no support. And so we found that an appropriate pile to take the calculated 780 kips of force on this bridge would be 8 feet in diameter and 66 feet deep. So let's talk about the roadway now. Okay, so looking at the soils under the roadway, there was some concern that we'd see some acidic soils. They're luckily non-acidic. And so they are also very low in silt. So because of that, they have very little collapse potential. So that's something we don't need to worry about. There are some expanding clays present in some layers, but there's really not very much, and we think we can mitigate any kind of deleterious effects from them by just mixing our soils. For our actual roadway design, we were given the easels by our traffic team, and based on those and just the measurements taken, we got a structural number of 4.95. Now this number is pretty large, and that reflects a fair amount of uncertainty that perhaps could be decreased with some additional measurements. But if we're just using this value, we can accommodate that with 6 feet of asphalt and 6 inches of asphalt and 18 inches of aggregate base. And now I'd like to pass it off to our structures team, starting with Joel Hernandez.
All right, thank you, Ariana. So right now, as you guys can see, that's how the bridge currently looks like on present day. And when we were designing this bridge, the first thing that we took into account was that when you're going up the bridge, there's 3 lanes that are merging into 1 lane, and that could cause a potential accident because of people that may be reckless or may just be distracted when they're driving on the bridge. So we coordinated with roadway, and we were able to get a new design going. And we decided to create 2 bridges, to design for 2 bridges, 1 for each direction, each having 3 lanes. Now the reason we did that is because it will be very more cost effective as we currently look through our different designs, because we also thought about widening the bridge. Now, if you would go on to the next slide, here's how the design looks like. And currently, that was one of our things that we were looking at. Another thing that we wanted to take into account was that the bridge is currently not up to code. And due to the rising population in the area, we noted that this was another main concern that we had. And one of the things we did was we looked at other structural elements and spoke with other entities. Now, Danny's going to talk to you guys about the drill shaft and other structural elements that we were looking at.
Thank you, Joel. What's important to take note of are 3 things. First, we had to coordinate with hydraulics to determine water level and freeboard height due to the 100-year event in Pantano Wash. Second, we had to raise the bridge approximately 10 feet vertically to accommodate the pathway below to allow bringing pedestrians from the southbound side to the northbound side in order to have them utilize the multi-use path as mentioned before. And third, the use of the 3-span design with AASHTO Type 5 girders at 120-foot spans totaling 360 feet from end to end. These design parameters will provide both benefits economically and, as mentioned earlier, are commonly used design practices in Pima County. As for the substructure, using HS20 loading per AASHTO standards and per traffic's recommendations, we were able to calculate the maximum axial load transfer of 780 kips each. With this information, Geotechnical was able to determine the required depth of the 8-foot diameter drilled shafts that she had recommended at 66 feet deep. Furthermore, due to the 3-span design, we were able to limit the cost significantly by utilizing less drilled shafts overall, as construction will point out later in this presentation. Next slide, please. Another aspect that structural had to look at was the design of the retaining walls along Houghton Road. As you can see in the slide, we provided example of ADOT's requirements for the design of these walls. Therefore, with geotechnical and roadways recommendations, we were able to locate these zones in order to provide the benefits as mentioned by Ariana earlier. Another area just as valuable as structural, believe it or not, is our very own environmental. Edgar is going to go over the environmental aspects of this project. Thank you.
Thank you, Danny. So the two kind of important aspects to consider for the environmental portion for the project is the SWIFT. And so the SWIFT kind of focus on the several points that include the soil types, disturbed area, control measures, training, and monitoring, as well as the BMPs showed on the site maps. And these BMPs include erosion, pollution, sediment, control parameters. And so in addition to these BMPs are also in compliance with the county as well as the EPA. So on the next slide is the Envision rating system. So the two kind of categories that we gained the most points from was quality of life and leadership. And both categories kind of focus on the well-being, mobility, as well as boosting collaboration, planning, and economic growth. So the score we got using Envision was 246 out of 504 points. And from this, we got the gold certification. So the kind of main point what we learned from Envision was that each project is unique. And using Envision, we were able to boost the sustainability and efficiency of the roadway for the community. So next we have Will discussing construction for the project.
So construction really took two methods to this project. First, our goal obviously was to maximize the pricing savings through both engineering methods in the design phase, as well as creative construction solutions in the construction phase, as well as give the owner a good idea of the total project cost and schedule. So in this first section here, we're going to talk about how we look at the bridge, which is one of the largest cost drivers on this project, and how we had two main options. So we could either refurbish the old bridge or construct two new bridges from the ground up. As you heard prior in this presentation, refurbishment of the old bridge had several issues with it. It would pretty much involve taking it down just to the piers and the caps, and then rebuilding a complete new deck that could sustain the size of this roadway, along with additional piers and caps to support the expanded roadway alignment. That didn't really save very much money. There wasn't much advantage to it. So we went ahead and took a hard look at the construction of two new bridges. Not only does this allow us to update completely to modern codes, it reduces a lot of unnecessary deck area where the median is by allowing just an air gap separation. It also allows for better construction phasing to minimize the disruption to the community. It also gives us an opportunity to completely document the new bridge with quality as-builts that are lacking for the current bridge. And these quality as-builts will make it much easier if the roadway ever needs to be expanded or reconstructed again in the future. So can we go to the next slide? Looking at overall cost, without project modifiers like contingency, maintenance of traffic, swept controls, the pure construction cost comes into about $17 million. With those modifiers, that boosted up to about $35 million. Factoring in final design as well as construction management services throughout the life of the project, that brings us to $39 million as the in-place cost for the owner. For the actual construction costs, the bridge is obviously the largest at $6.2 million, followed by earthwork at 4.8, pavement costs at 2.9 million, and concrete costs at 2.2. It's important to note that this concrete does not include any of the structural concrete for the bridge or abutments. It's mostly flat work and bus bay paving for future bus bays for SunTran. All right, next slide. Getting into kind of a proposed sequence of schedules, we have 4 linear phases and then one phase 5, that doesn't necessarily fit in linearly. We're going to start with our northbound section. This will be a completely new alignment outside of the scope of the current roadway. So we'll get in there, we'll clear a way for it, get access to the watch, completely construct the new bridge, complete the earthwork, the flat work, and all the initial paving, and then prep for landscape. This will give us a roadway that we can shift our current two-way traffic onto for phase 2 and 3. Phase 2 and 3 would involve demolition of the existing southbound bridge and alignment, and then reconstruction of that alignment to the new, 3-lane across with median and bike paths standards. Phase 4 would kind of be the final touch-up. That would include any final landscaping, and then a final lift of asphalt throughout the whole project. So that way, during construction, the shift overs, we're not marring the final drive surface, and it looks good for years to come, as well as any site cleanup. Phase 5 is, as I mentioned, that out of sequence phase. That's so we can conduct work at Seacrest Middle School when it's most convenient for TUSD. You don't want to be building on a school during the school year. That project needs to mostly occur in little sections during the summer months. That way we're not interfering with that learning environment. All right, I'm going to pass it off to Jess now to discuss utility coordination.
Okay, thanks, Will. So this is just a quick overview of all the existing utilities that we're currently having on site. They're pretty common companies found in Tucson. The main overhead utilities located on this project are owned by TEP. There's 2 major lines running along the boundaries of the project, the power lines and then the distribution lines. Our main concern is the power lines located on the east side of the road, running the entirety of the project, for they're in close proximity to the existing roadway, and they'll need to be relocated. Bearing these lines has been taken into consideration, and we plan to do that for the majority of them. The distribution lines are located on the west side, running on the southern end of the project, and will also need to be relocated in order to widen the existing road. And if we go to the next slide, these are the underground utilities we anticipate on relocating or protecting during the construction phase. And these are all explained in more detail in our report. So just for time reasons, I'm not going to go into too much depth on those. But with this relocation of the utilities, here at T3, we see the importance of coordinating with those companies and also the agencies involved in the project. Ownership and prior rights is discussed in order to relocate each utility to standard. So our communication with the city, Pima County, RTA, and the U.S. Fish and Wildlife Service ensures that we have a smooth construction process. We have confirmed that the project area does not occur with any critical habitats, which is a good thing. And then if we go to the next slide, as we know, construction of the road is anticipated to take several months to complete, and the surrounding land is primarily residential subdivisions. So here at T3, we understand the burden that the extensive construction work can place on the surrounding community. Therefore, the neighborhoods and businesses will remain open and accessible all throughout the construction phases. We plan to do this by maintaining 1-lane traffic in each direction at a minimum. And then the existing bridge will remain open while the new bridge is being built. And then once that's completed, the traffic will switch, allowing the existing bridge to be updated. And then when it comes to that middle school, like we said, we plan on not doing construction while it's in session and over the summer, but if push comes to shove and we have to, we do want to also coordinate with the district to ensure the students, the faculty, and the parents are all aware of the construction going on during the school year. And now I'm going to pass it on to Rima to end the presentation.
Awesome. Thank you, guys. All right. So as you can see, this project has required a great deal of cross-discipline collaboration. Some of the key features here, such as our 6-lane roadway, the multi-use pathway, the ADA compliance improvements, drainage improvements, the new bridge, and even the land that we've reserved for future bus pullouts, have all ensured that our 20-year design will continue to service the community as it grows. Now, keep in mind that the plans that we've presented are about 15 to 20% complete. So we still have more refinements to make, more collaborations to work through, more improvements to come. Now, with that, we'd like to thank you guys for your time and ask you if you have any questions.
Hi, this is Anna. I have a question on the cost, and I might have missed it, but what did you mean by the modifiers?
So the modifiers were a set of pre-given percentage add-ins that we were given from the instructor. In this case, they would likely include the contingency just to account for the fact the project's not fully designed yet, so we can't do a complete cost estimate. That was 40%. Right off the bat of a cost increase. So we took the construction cost, multiplied it by 1.4. That was our contingency. And then on top of that, it's additional costs that don't go direct into construction, but do need to be paid for on the contractor side. Like field offices, overhead of the contractor itself, maintenance of traffic, SWEP, things like that, where they don't directly impact the construction cost, but when we're budgeting for the owner, they still need to understand that they need to have the money in the project for that, but they don't deliver a direct value at the end of the day.
Okay, thank you.
This is Kevin. I'm wondering about this. I think you're talking about channel widening, and I'm not completely clear on where that is, how much the widening is, and then how far upstream and downstream of the bridge that widening will occur. And can you explain that a bit more, or am I just missing something?
So we tried to maintain the natural wash cross section as much as possible.
Hello?
So are you referring to the 360 foot? Is that you saying that's too much?
I'm sorry. I had my when I hit the speaker off, so you have to start again. I apologize. I had the speaker, not the mic off when you started talking.
Oh,
So
okay. Can you hear me now? I'm
yes,
sorry.
I can. Sorry, my apologies.
This is Danny. It's good to hear you again, Lancy. So to answer your question, are you referring to the 360 foot as being too big for the channel, or are you referring to the drawing?
I thought when I saw the HECRAS model, I thought the discussion was that the channel was going to be widened near the bridge, and
as far as I know, there's going to be some rework for grading to accommodate that footpath that's going to go underneath the two bridges. That might be what he's referring to. And I'm pretty sure that construction also took into account the cost that it would take to make sure that there's safety railing on the side of that for that, and also the shotcrete or some kind of hardened earth so that the erosion from the water doesn't occur too rapidly.
Mm-hmm. Okay. I misunderstood what was being said there. Thank you.
This is Frank. I've got a quick traffic question. When you described how your design year volumes were calculated, can you go over that again?
Yeah, sure. So for the volumes, we had two sets of counts. Well, one that we were given from the professor, and that was counts taken from like a third-party organization that took counts on a particular day. So that was ADT counts. And then I also took counts from PAG since I needed to determine what percentage I wanted to increase for the next 20 years. So from PAG, they gave me the last 6 years of counts for each year, and as well as a percentage of growth rate that they determined for the past 6 years. From that, I took an average, which gave me about 5%. So then I multiplied that 5% by the 20 years, which gave me about 100% increase, which is basically double of the existing. And since I wanted to be more conservative, I decided to take the counts that were given to us, since it was about like 3,000 vehicles more than pad counts, and I just multiplied that by just doubled it, and that gave me my future volume for 2040.
Okay, so there was a conservative number based upon an initial growth rate, though.
Yes.
Okay, thanks for the clarification.
Of course.
This is Doug. I have a structures question for you. It sounded like that you had you've selected the an ASTO girder bridge. Did you review other options?
Yes. So we in our DCR, I don't know if you read that or not. We basically had three separate options. The first option was to maintain the force span using pre-stressed type 4 girders. And then the second option was analyzing that force span with steel girders, fabricated and then shipped in and placed. And we found that the cost for those two options was a lot higher than the cost for the 3-span with the type 5 girders. So we chose to present the option 3 because due to time restrictions. So I apologize for that.
Oh, thank you. Yeah, the DCRs were quite verbose.
Any additional questions from anyone? Well, I thank all of the members of T3. You guys did a great job. It was a long haul since August, but we're through them all. Everybody did a great job. So you're welcome to leave the meeting whenever, and thank you very much. And the judges and I'll hang out so we can chat a little bit afterwards.
Awesome. Thank you, guys.
Thank you,
Thank you,
guys.
Sal. Thank you, judges.
Thank you.
Thanks, guys.
See
Good
you,
work.
Lancy.
Good job.
Yeah.
Congratulations.
Congratulations,
Good job, guys.
guys.
Bye, Lancy. We'll talk to you soon.
Yeah.
All right, well, it's back to the 5 of us, I guess. So, any questions before we close out? I will add that we did have a big disparity in the construction costs. The Team 3, huge cost.
I'd say.
I was going to ask about that.
And then Teams 1 and 2, they had similar costs. You know, it was Will Vale is actually the son of Bill Vale.
Mm-hmm.
And so he, I know that he was very deep into the cost estimate, and I think Team 1 and 2 were too low, and I think Team 3 was too high. It's somewhere in the middle. You know, because I mean, their cost for the bridge alone was $6 million.
Yes.
And I didn't bother to do a square foot on that. I just haven't had a chance to really look into their numbers. And then on the one thing we wanted them to do in the cost estimates, we wanted them to, anything that they could quantify, they needed to quantify. Anything that they could do an allowance for, we wanted them to do an allowance for, such as landscaping, such as drainage, just by, looking at previous jobs and saying, well, the drainage items added up to this much, per square foot of surface area or per linear foot of job, to come up with an idea of how to come up with an allowance that, because you don't have any drainage work done in terms of surface drainage and on the roadway and things like that, or landscaping. And so they had to come up with allowances, and then, for any category they didn't have a number for, like signage, and that they should, come up with an allowance so that all the categories were covered. Then afterwards, we had them take a 40% contingency, because we were calling them basically 15% plans. And then along with adding on to that, they have the fee for engineering design work that has to be done. There's a fee, there's a cost in there for construction administration that has to be done. And so all those things then further add to that 40% contingency. And then we gave them a cost of $50,000 an acre, just as a number for any right-of-way. So they had to add any right-of-way additions, to that number. And I think we had a couple percent in there maybe for archaeological stuff. And so there's some additional, everybody had, once they got to their detailed construction cost subtotal, then all the ads were supposed to be the same for all 3 teams.
Okay, good.
So I was very pleased at how smooth this ran today.
It was.
I just envisioned, not envisioned because, but, kept thinking, God, something's bound to blow up here somewhere along the way. But it went very smooth. And so I was very happy with that part of it.
Yeah, I think they handled it really well, and there's only a couple of glitches with slow internet.
Yeah, yeah, yeah. So no, I'm very happy. It's tough for them to come back from spring break and get going again, and on top of spring break being, everything going to non-classwork stuff, many of them were involved with the ASCE Pacific Southwest Conference, and that got canceled. So all the work they put into that this whole year basically just, didn't go anywhere. They didn't get to go to California. So they had some things to deal with too. And so I was very happy with the results. And I thought all three teams today presented quite well.
Yes.
I'm not trying to influence any scoring, but I was keeping my own scores along the way, and I had them reasonably close, I thought. So.
Yeah, no, I thought they were all pretty close, and seemed like each team had a couple of really strong presenters and a couple that were a little on the nervous side.
Yeah.
But I think they, for having to talk into a camera and not be able to see body language or facial reactions.
Right. Yeah. Yeah, and then of course, the last team talked more about utilities. Team one didn't talk very much about Secrest, the importance of that middle school along the way, and so they made some decisions along the way as to what things were important and not important to discuss. So they those are things I noticed more because I was closer to what their scope of work was. But yeah, overall, I thought, and we had a few people that were kind of short. They had like 2 slides and they were in and out, not much talking. But, overall, like I said, I'm very pleased. I thought they did equal to what I've seen the last 2 years. And I think these kids are coming through. They're getting well prepared in their other classworks and some of the other opportunities the U of A offers them. So I think, I can tell you back in 1973 when I got my bachelor's, there was nothing close to what they do now in terms of some of these things.
Yeah, I was impressed. I thought they did a very nice job, and I thought you got them doing a lot of good work, and I think that's a change for some of the things in the past. So I thought they had something they could really be proud of, and even as individuals take to their bosses or their new bosses and saying, "Here's what I did," and be proud of it. So I thought that was really good.
Yeah. Yep. And we had, I didn't pass them on to you guys, but we had like weekly progress reports from the project managers. And this is the first year we've had a project manager assignment for the team. So that was, it was a really good addition. Up until then, we had the major disciplines, the same major disciplines, but we had a person volunteer to be the team leader. But this year we added a discipline. Well, we had 7 disciplines before. This year we added project manager. And so they didn't have to do an individual technical report, but they had to run the team. And the 3 kids that ran the team did a great job.
Mm-hmm.
And, they turned in weekly progress reports, and it was interesting to see that as the end got closer, as how they grew more and more as a team. And one of their comments was that, we really, the teaming really kicked in. And, I explained to them too that, when it gets close to the end, some of you are going to be done, some of you won't be done. Y'all need to help each other out and get finished. And there were comments like that other people did pitch in and do stuff. So I think it was a great teaming experience for them too. Has been, and I think adding the project manager was a real benefit for us this year.
Did the team select who their project manager was going to be, or was that
The
identified?
way it works is we do I do a class survey, and I list the 8 disciplines of what they're expected to do in those 8 disciplines, and then they rank them 1, 2, 3. Actually they rank them 1 through like 8. So what would you like to do the most? What would you like to do the least? And then I go through and I look at that information. I also ask about internships and other things that I try to balance it out. And I look through them and see, you know, we try to give everybody their first or second choice for what they participate in. And we pretty much had that this year, except I think 2 people had to take their third choice. Actually, like Geotech, I think, you know, we had like only 2 people pick Geotech as their first choice, or maybe only 1. So it's hard to get, you know, but so we do that. And I also look at them, and I go through them. I look at them by like grade average. I give them like a little score that I just make myself up as to what their experience is. You know, some kids have a lot of internship at work. Some have some familiarity with drafting, and then I try to balance those scores out between the teams. As I start selecting, you know, I go through and pick the project managers for each one, and then a roadway person for each one, and then try to balance it out so that you know, the overall grade average for the team is the same. They're very close. Also, their amount of experience in terms of leadership, you know, what have you participated in, you know, and they, you know, what kind of jobs have you had? So I have like a score for that, and a third score. So I try to get those all to kind of balance across the 3 teams, so that the teams are balanced, you know, because they're not allowed to. We don't let them pick their own teams, otherwise, you know, it could be a real disparity in terms of you know, who teams up with who. And it's also a good learning experience that they get to work with people they don't know, and people that might not, you know, work as hard as they work, or work harder than they work, and maybe they can learn something from them. So it's worked out well. This is my 3rd year coming to an end, and every year we've managed to improve, I think. And so that's kind of how we pick them. And
so you have the next project figured out, Sal, for next year?
I haven't yet. I'm a little concerned if I'm gonna get my job back, if I'll be part of the people being axed by the university. So, but no, you know, some of our problems have been, you know, is finding. We've had problems with drafting and getting the plans done, and the plans that are created, you know, by the roadway people on the team. And Frank's been deeply involved and been a big help with it. He teaches a drafting roadway design class in the fall. And so typically kids from his class end up being the roadway people for senior project because of experience in it. The first we did it, we had a lot of problems with. We weren't lined up in terms of the software we were using and what was available to them, and we have to get projects that have all the background info available to us. So the first year we really struggled with the drafting part. Last year, used the project that Frank's firm had done, and they were able to give us all the backgrounds and stuff, and that went much easier. And this year, it even went it went easy as well in that respect, because we had all the right AutoCAD drawings, and the kids could start drafting and doing the work and help. So and Frank and I worked together so that what Frank was assigning them to do and using to learn how to do the drafting stuff was actually their senior design project drafting efforts as well. So we were able to get some of that work done up front, and so that they were ready to go once second semester came around. So that's been a real challenge for in that part, and we've really come a long way there. But I don't have a new one picked yet, Frank. I was trying to think of what might be good out there. You know, we could possibly do another piece of Houghton Road. I don't know if Doug's got any ideas what ADOT might be having designed. I thought about possibly, you know, but I think the Valencia job's almost done. Isn't it the one that's under construction, Anna? Do you know?
The one out west, yeah, they're doing final paving in June.
No, I mean over the one for Diamond out over the Pantano.
They're not. They're under construction. They started September, so about halfway through, maybe.
Yeah, but their design, so their design's done already.
Oh, yes, yes, yes.
How far along do you want it to be? Do you need it to be, so?
It doesn't need to be very far along, but we need to have all the drawings and all the, we need to be given all the files for us to use in, what are we using, Frank? AutoCAD 3D or MicroStation 3D?
Yeah, the Civil 3D through
Civil.
AutoCAD. Yeah.
So that's the thing, because that's the software that's available to the students, and so we need a project where someone will give us all the back, like this year, SOMAS, this part we did was a portion of SOMAS's work on Houghton Road, and the portion that, and so SOMAS gave us all the backgrounds. So we had all the existing data, we had all the topo, and so that was, extremely helpful because they gave us the files with the existing roadway modeled in it already. And so then basically our kids then basically had to, now they could take that, that existing model, move the roadway east, west, and realign it. And they didn't have to create that part of it. They had to understand the design parameters, vertical curves and horizontal curves and whatnot. But they didn't have to build that part because we can't make it a drafting. It can't be really, it's supposed to be senior design. It needs to be a drafting. It can't be a drafting course where they're learning to do the drafting work. They need to be able to do the design work as at the point where some transportation tech would give them all the drawings and they could start then working on them themselves. So that's the challenge, Doug. I mean, if you know of somebody that's working on something, it's got to be local so they can go out and see it. I mean, it can't be, and I don't know what you guys might have on some of the upcoming, even some of the possibly, the bypass, the Sonoran corridor stuff. There might be something in there or some other piece of roadway in there that we could, get involved with. But yeah, we have to come up with something for here.
Okay, yeah, I will certainly keep that in the back of my mind. I know challenge coming from ADOT is most of the design files are, MicroStation and En-ROAD, so we would need to work with the volunteer design firm to convert that all over for your guys to be able to use it in Civil 3D. But I'm going to guess that there will be a number of firms that be willing to assist with that.
Yeah, we'll have to, it's something we definitely need to, start talking. I mean, this one's hardly over and we've already got to come up with an idea of where we're going, next year. I'd like to accelerate some of what we do next year and even start the design. We start basically the design portion in January. They do an SOQ, then they do some planning in the month of November and how they're going to attack it, but they start their design work in January. I'd like to get all that moved up another month to give them a longer time to design, because come January, when we start to design here, we have, before they go to California or wherever they're going for the conference, which is kind of like a week that nothing gets done because they're all so busy. They're out of town the last half of the week. They're preparing. So we lose a week there. We lose a week of spring break. And, if you don't get the project done before those 2 weeks off, then you just lose too much momentum. And, everything, you come back and it's now, mid-April and you're trying to turn your DCRs and stuff in. And our plan this year was to have got the DCRs done right after spring break and in between the Pacific Southwest Conference. But then, everything got turned upside down. But yeah, I'd like for them to be able to get done, early enough so they wouldn't have to worry about, the downtime that they experience, because the spring break and the Pacific Southwest Conference are like they're within a couple weeks of each other. So it can be a real killer in terms of killing momentum. But thanks, Doug. We can talk more about it. So what are your preferences now? You're gonna finish up your scoring. You're just gonna email them to me by tomorrow morning sometime or tomorrow noon. Is that everybody's plan?
That is my plan.
Okay.
Do you have a deadline of when you need them by?
Oh, I'd like them tomorrow so I could summarize them and have them ready to talk to the class on Thursday
Oh, okay.
about the scores. So if I could get them tomorrow, that would be fine.
Okay, I'll do that. I'm going to leave now. I'm not home yet, so
Yeah.
I'm going.
Drive safely. Well,
I
thank you
will.
very much.
And then I'll send it. I'll finish them up tonight, and then I'll send them to you tomorrow morning. Okay.
That'd be great.
Okay. Thanks, Sal. Nice seeing you.
Thank
Nice seeing
you.
everybody
Yeah, we
else.
only have 2 classes left. Next week from today, they're done. So semester's over.
All right. I'll talk to you later.
Doug, Frank, you guys all okay with getting me something by midday tomorrow or so?
Yeah, I'm trying to.
Or tomorrow night?
Trying to pull up my calendar real quick to see what Wednesday holds for me. I've got some pretty good notes tonight, so I just need a little time to summarize it. But I think I can have something to you by midday, Sal.
Okay, that'd be great. That'd be great. If you need more time, that's fine. I mean, I can just push it to. They won't get the results till next Tuesday, which is last day of class, and I'm just trying to avoid having so many things on last day of class, you know. So, okay.
And I'll get your stuff, Sal. I'm gonna try to get it.
All right.
Yeah, no, well done, Sal. That's a challenging way to end the semester.
Yeah, we were very fortunate the way things timed out for us. I mean, we were already into teams working on their own. Just that everything had to become internet bound by this point. So you know, we didn't lose anything we were trying to achieve. So that was good, but it just had to be achieved in a more difficult way. All right. Well, thanks everybody.
All right. Have a good evening, guys.
All right. Thanks everybody. Have a good night.
Bye.
Bye-bye.